Hey guys, I'm Ishwant, and today I'll be presenting about modeling and assembling of the British Leyland Mini 1000. Um, so if you go back into history and see one of the greatest comic series is Mr. Bean. And when we talk about Mr. Bean, the three things that come to our mind are his antics and quirks and Teddy and the beautiful green and black car. So back then, I didn't know what was the car or the model, but I'm really glad that I chose that as my project topic, as it's a wonderful opportunity in order to create your dream car in a 3D CAD model. So I started really basic by drawing this terrible drawing of the car, and then I went forward with some pictures from the research I have done, which are just an exterior pictures and interior pictures of the car back then. So the British Leyland Mini 1000 is a small economic car produced by the British Motor Corporation. It actually started in 1959, but has undergone a lot of design and manufacturing changes. So there were a lot of different manufacturers, now popularly known as Mini Cooper. And there were also a lot of design changes. If you go back and see the actual Mini Cooper and the British Leyland Mini of the Mr. Bean's car. So as there was a time constraint of 21 days for completion of the project, I divided this into different stages and went forward with the smaller parts, starting with such as chassis, wheels and steering wheels. And then I went on to do the actual outer structure, which is the superstructure of the car. And anyone who did surface modeling, which we encountered in both American Chopper and the Yacht, would know there will be a lot of intersections, interference, and errors and complications. So I put major chunk of my time and energy into making the superstructure, working on the superstructure. And while during this process, I also raise my there was a lot of increase in my appreciation for the manufacturing industry, as while working on this I understood that it's pretty difficult in order to manufacture such things from a simple design by an engineer. So the automobile industry is one of the world's largest economic sector by revenue and is a key demographic for the mechanical industry. And Solidworks, being the 3D CAD designing software, has become the bread and butter for the industry, as it allows for the visual representation of the product before manufacturing. So the 3D CAD designing is a really good investment by the industry, as it actually helps both engineers or the market researchers or the company itself, as it allows us to design the model before the launch, so we could test not only test the physical dimensions or the appearances, but actually go on with the analysis part, which helps us to see if the product is shelf ready, or is it ready for the customer use, or is there any changes to do. And that is a really a good boom in the industry, as if we go back and see that there used to be a lot of trouble in the engines or something like that, but now with proper flow simulations we could actually we reduce the number of issues. So by learning the mistakes in the boardroom stage itself, it's really a good thing for safety of the people. So I started with chassis, then the steering wheel, front seat, back seat, superstructure, door, assembly, and finally the render. And the chassis was chosen as the first part to model, as it was the base of the parts and a reference to all other parts. In general itself, chassis is the base, as the axle of the wheel, muffler, or the engine or anything is actually mounted on top of it or bottom of it. So designing that is a good choice on my part, because it actually helped me in order to understand the proper dimensions and how should a wheel, even if there's changes in the tire or something like that, I could visually see by doing a simple assembly of the tire and the chassis, such thing like that. So the chassis basically is a boss extrude of the dimensions that I found through my research of the actual car. And then after the boss extrude of the actual geometry, I also designed axles, which are basically the front axle and back axle, which is also a simple boss extrude of a circle. And then in order to have a better understanding of better visual view, I also designed a muffler in addition to that to the rear of the chassis. I went on with the steering wheel, which is a simpler one as well. Instead of choosing a circular extrude and then having an extrude cut, I went on with a sweep and then mirrored that sweep in order to get a proper handle, and then a simple horn in the center of the wheel, and then 3 quadrilateral shape extrudes connecting those. Nowadays, if we see the car steerings right now, which are pretty nifty, as they have a lot of tech involved in it, a lot of padding, leather grips, a lot of luxury now that is involved with the steering wheels. But back then, it's basically designed for its purpose, which is basically just use the horn or just to rotate the wheel around. So I didn't want it to change much to the interior, as it takes away the magic of the actual car. So the wheel, thankfully we did the American Chopper and American Chopper before the independent project, because while working on the American Chopper, we designed the front wheel and back wheel. So taking the principles from that actually really helped working on my wheel, as I use the same principles, such as revolving a rim first and then a tire on top of the rim. From my research, I found out there were no changes to the tire of the mini cars for a long time. So I did a revolve of the rim and then the tire, and then some detailing such as dome feature and fillets onto the rim, and then treads were also applied according to the pictures I have went through. So as I was talking about how minimalistic people back then were on the interior parts, so the front seat and back seat now are a huge luxurious thing, as we have a lot of lumbar support or a lot of recline to it. But back then, it's basically a park bench in the interior of a car. So these front seat and back seat are boss extrudes, and then boss extrude cuts and fillets. And then in order to get the passenger seat of the front seat, I use linear pattern. And the back seat as well is a similar thing, similar sketches to the front seat, but the dimensions obviously changes, as the back seat usually is larger than the front seat. And then instead of the linear pattern, I use the mirror feature in order to mirror the seat. So finally, the dreadful time of working on this independent project was working on the superstructure. As I was talking, how hard it is to do the surface modeling. So no matter how good a car is in terms of performance, but people, and to an ordinary buyer, the outer look of a car matters a lot. So to also bring out the life of the Mr. Bean car, which was in my mind, the superstructure plays a major role. So from the yacht modeling, while doing the yacht modeling of the superstructure of the yacht, I back then thought that this looks eerily similar to the actual car. So that really helped, as I used the same principles of the superstructure of the yacht. So for this, while working on the superstructure, I started with bringing on the chassis into the environment, and then use sketch pictures, the blueprints of the Mini. I didn't actually find the Mini that I wanted to design, so I brought in the Mini Cooper blueprints, the sketch pictures, which is similar to in terms of dimensions, but a lot of differences in details. So the surface modeling involved like creating the wall first with a lot of projected curves, surface loft, surface fills, and then going on doing a surface fill of the top, and then connecting everything really well. And the superstructure includes some make-believe things, such as bonnet, boot space, such things. And as they were basically just an extrude cut onto the superstructure. So once I was done with the surface loft, I went on to create the once I was done with the surface modeling, I went on to create a solid, and then did some detailing such as taking out the door using the split feature to design the door separately, and then adding some few lights, bumper, and axles for the steering wheel inside the interior. So that was the surface model. And then as I mentioned, how I took the using the split feature, I took out the door and then added hinges to the side of that, as I wanted this to be a dynamic feature. As I was talking, I took an effort in order to make the steering wheel and front seat and back seat, so it will be pretty good to in order to open the door and then go on inside and check. So the hinges were basically a circular extrude on the side, and then an axle on side to the superstructure was simultaneously made. So that was the assembly. So assembly didn't took much time, as there were not a lot of parts involved. So I started with the chassis and then built from there as I brought in the superstructure. So as we brought in the chassis while building the superstructure, it was pretty easy. No mates were required there. So, and then tires were used. The coincident relation between the tire right plane and the chassis right plane, and then concentric relation for the axle so that they could rotate. And then the front seat and the back seat were also placed, and then the same coincident and concentric relation for the steering wheel was also in place inside the car. And then the door was fixed at the last with the hinge, with the concentric relation. Finally, the rendering. As this was the final stage, I wanted this to look good. So despite not having a lot of changes in the rendering environment, I basically changed the environment, and I didn't want it to be pretty basic, which is usually we have a road or a studio environment. So I wanted to have it a salt track theme, as it felt like it would be an advertising or a marketing opportunity for the car. And then I used an accurate and 2000 passes for the rendering. I also, there were small details such as scaling the model, attaching it to the floor, depth of view, and a few things. As there were all the appearances and all the appearances were taken care of by the Solidworks. There was not much required in the Solidworks visualize. So these are few rendering pictures. So I would like to start by thanking Skill-Lync for giving me the opportunity to pursue my dream. I'm grateful as this actually helped me in order to actually fall in love with the software. As before we were just working on the PDF videos. Now that we have disconnected from that and have no source, actually didn't went on searching a lot on internet. I wanted to use my skills learned from the past two projects, and the 21 days actually helped in order to me to be really time as there was a time constraint. I had to be pretty disciplined in order to finish this. I know that it's not the 100% true model of the car, as that would have been great, but it's actually pretty nice that there were mistakes made, because I know that after completing the project, I realized I could have done that better, did this better. And as people say, this is not a sprint, but it's a marathon. So I'd like to take this time and knowledge and then put this forward and try to not repeat these mistakes. So I was talking about the project scope, which is Mr. Bean, watching Mr. Bean series and having this, watching this beautiful car. And I'm really glad that I pursued mechanical engineering and, using the CAD software to make that dream come true. There are few changes in the car, such as the tire size. It's actually my preference in order to have the larger tires, because I don't know, for some reason I really liked larger tires, and when I used to watch Mr. Bean series or the pictures while researching, the tires are pretty small for the car, really thin, like having a motorcycle tires. So I wanted these to be like standout features. And thank you.